Hi, I'm Kim from the University of Melbourne, and in this video I will present a decision support system for incident response using a large language model. In the last decade, the volume of cyber attacks and their cost for society has grown rapidly. And this trend is only expected to continue in the coming years. A key solution to manage the increasing costs of cyber attacks is effective incident response, which refers to the coordinated actions taken to contain, mitigate, and recover from cyber attacks. Currently, incident response is managed by security experts in so-called security operations centers, as you see in the figure here. However, right now we have a global shortage of around 5 million of those experts. As a consequence, there's a strong need for new systems that can assist security operators in managing incident response. To address this need, we have developed a new decision support system for incident response that uses a large language model to automatically translate system logs into response plans. Our system consists of three main components: fine-tuning, information retrieval, and planning. To demonstrate our system, I run it on a server where I have downloaded a fine-tuned version of the DeepSeek R1 LLM with 14 billion parameters, and I use the OTX Threat Intelligence API for information retrieval. This is the web interface of our system, where the user can log in and navigate to the incident response service. This is the configuration page where the user can enter details about the incident and also about the affected system. Before generating the response plan, the user can also control the planning depth and the temperature of the LLM. The first phase of generating the response plan is information retrieval. During this phase, we parse keywords from the information about the incident and use those keywords to retrieve relevant information from external sources, such as threat intelligence APIs and vulnerability databases. Given the retrieved information, the second step is to assess the severity of the incident and generate an incident report using chain-of-thought reasoning. The last step is to generate a sequence of response actions. We do this using a decision-theoretic planning algorithm based on look-ahead optimization. More specifically, for each action, we start by predicting the current state of recovery from the incident, which you can see to the right on the screen. We then use that state to prompt the LLM and ask it to generate several candidate actions. And for each of those actions, we simulate the system to evaluate how long time it would take to recover from the incident if we take that particular action. Finally, we then pick the action that leads to the shortest expected recovery time. Once the planning process has completed, the output of our system is a complete response plan together with an incident report. This information can then be used as decision support for a security operator and help them to reduce the time and effort to recover from the incident.